In this video today, I will review a paper of our own. The paper's title is Introduction to Soft Cryptosystem and its Application. The authors are me and my guide, respected sir, Professor Shyamol Kumar Mondal. The article has been published in the Wireless Personal Communications Journal under Springer. The online published date is 26th February 2022. The soft cryptosystem is based on two fundamental concepts. The first is subset theory and the second is cryptography. And therefore, the subset theory has been integrated with the field of cryptography. So, before starting the discussion of this paper, I first give some basic ideas about cryptography and subset theory in short. First, I start with cryptography. We can recognize this guy. He is Mr. Barack Obama, the 44th President of the United States. This is the snapshot of his verified Twitter account. We can see an announcement, all Bitcoin sent to my address below will be sent back doubled. If you send $1,000, I will send back $2,000. This message was there in his verified Twitter account for 57 seconds only. But within a fraction of a second, this message goes viral. And not only him, if we look at it, it was the verified Twitter account of Bill Gates, Elon Musk, and not only that, during that time, Joe Biden was not the President of the United States, but still many other celebrities in verified Twitter account, the similar message was reflected. But after a few hours, it was found that it was a story of July 15, 2020 during the lockdown period, and seen that it was a scam. The scam is known as the Twitter Bitcoin scam. We can understand that we certainly require cyber security for anything. So nowadays, especially during this COVID period, everyone is working from their home. As a result, this digital network plays the most crucial role. So we need strong security. Many of us do a lot of online shopping. For example, when we buy something using our credit card or debit card, the process is not that simple. Suppose I punch my debit card at some supermarket. Even if we are very close, but the transaction occurred differently. So broadly speaking, it first goes to some the order has been placed, some third party would be there, then some payment procedure would be there, some gateway would be there, then it will go through some bank, then the bank or the third party will pay the money to the merchant. So it is not that easy that it is done through only one step. It is through many steps, but it is happening very spontaneously within a few seconds. But there are plenty of individuals. More detailed steps involved while somebody buys something using their credit card or debit cards. For message transmission, in the case of WhatsApp, we will hear about the term end-to-end encryption. In the case of end-to-end encryption, as well, security is quite essential. So the question is, what is cryptography then? The term cryptography came out of two Greek words named kryptos, which means hidden, and graphia, which means writing. So cryptography is nothing but the art of writing secret messages. So a few terms related to this cryptography are as follows. Suppose the person who sends the message, call them the sender, and the person who receives the message, called the recipient. Now the problem is, a bad guy is there to listen to what is being sent. Suppose this boy want to send some message. The original message is known as plaintext. Now the problem is, since this bad guy is in between, as a result, whatever, if the plaintext is sent, then this bad guy will also be able to know what the plaintext is. So the boy will not certainly send a plaintext, but he will use some lock and key. So he will lock the plaintext to get the ciphertext, and this locked message will be sent to the girl. So the process through which the plaintext is converted into the locked message, which we call ciphertext, which we call ciphertext, is known as encryption. So encryption is a mathematical process through which plaintext is converted into ciphertext using some key. Now the girl will receive the ciphertext. Unless the key, the girl will also not be able to get the plaintext. So the girl will use a key to recover the plaintext from the ciphertext, and this process is known as decryption. So again, decryption is a mathematical process that converts the plaintext into the ciphertext into plaintext using the key. And the two things, encryption and decryption, together are known as cryptography. So cryptography has two parts, encryption and decryption. On the other hand, like the bad guy, there could be another bad guy who are always trying to find some weakness about the scheme, through which this guy converts the ciphertext into plaintext. This process is known as cryptanalysis. That means, using analyzing this cryptographic scheme, they will gain some information about the weakness of the cryptographic schemes. So these bad guys are known as adversaries. So the adversaries are the bad guys who want to analyze the cryptographic scheme. Cryptology is a more significant subject. It has two different parts. One is the constructive part, which we call cryptography, and another is the destructive one, which we call cryptanalysis. If these two keys are the same, we call it symmetric or private key cryptography. And if these two keys are different, we call it asymmetric key or public key cryptography. This is a historical cipher known as Caesarian cipher or shift cipher. It is believed that Julius Caesar used that kind of scheme. That's why it is known as Caesarian cipher. Suppose at some point in time he had some war front, and some of his subordinates, say his commander, he is also fighting at some other place. But during the war, they require some information to communicate with each other. So the question is how they usually communicated during that time, and that is known as Caesarian cipher. So the idea is, before going to the war front, both of them decided that we would use k equal to 11. Mind that that was the secret only known to them. Suppose Julius Caesar wants to send the message, cryptography is fun. Now the question is, what message he is going to send? He is going to send this message through the carrier. Now the carrier will carry the message and he will reach the place of the commander. The commander will receive this message. Since both know that k equal to 11, will get the original message quite easily. The question is how Julius Caesar converted the original message into this by using k equal to 11. So here the plain text is cryptography is found and k equal to 11. Now what Julius Caesar did? At that time he usually did in Roman, but for this time let us try to explain in the English alphabet. So we know that there are 26 alphabets in the English alphabet, and consider that A is assigned to 0, B is assigned to 1, C is assigned to 2 and so on. So there are 26 much many. Since we have started from 0, so Z will be 25. So basically the roll number of A is 0, the roll number of B is 1 and so on. So here cryptography is fun is the plain text. Now k equal to 1, it means each of the alphabets shifted to the right cyclically 11 times. For example, here roll number of C is 2 and that will be shifted 11 times to the right. That means C plus 11, that is 2 plus 11 equal to 13. So let us check which alphabet is for 13. It is nothing but N. So C will be replaced by N. Similarly, R is 17, and if we shift 11 times to the right cyclically, that means 17 plus 11 equal to 28. So we divided 28 by 26 and considered the remainder. The remainder will be 2. So let us check which alphabet is for 2. It is nothing but C. So R will be replaced by C and so on. He will cyclically shift 11 times every alphabet to the left when he gets this message, and he will get back the original message. So mathematically shift cipher is a 5 tuple. The first component is P, that is the set of all plain text. The second component is C, that is the set of all ciphertext. The third component is the set of all keys. Fourth component is EK, that is the encryption rule, and the fifth component is DK, that is the decryption rule. Here C, P and K are Z26. EKX is x plus k modulo 26 and DKY is y minus k modulo 26, where x and y belongs to Z26. Here the possible number of k is 26, so the size of the key space is 26. So we need to do only 26 options to break this scheme. So if I increase the size of key space, one question could be, will that give me more security? It will provide us with more security. Suppose there are two schemes. The first scheme's key space is 26 and the second is 40. Then of course the second scheme is better than the first scheme. Because for exhaustive search, the second scheme requires 40 searches, whereas the first scheme requires only 26 searches. The motivation of our proposed article is this concept, so I repeat the idea: greater key space size gives a more secure cryptographic scheme. This is the affine cipher. I am not going to the details. This is the substitution cipher. Now I give some basic concept about subset theory. Various types of uncertainties present in our day-to-day life problems. There are several theories: probabilities theory, fuzzy set theory, rough set theory, which we can consider for dealing with uncertainties. But all these theories have their complications. To overcome these complications, the subset theory has been introduced. Then one question may arise: why do we have a subset? One of the fuzzy set theory deficiencies is how to set the membership function. The nature of the membership function is extremely individual. Everyone may understand the membership value of 0.6 in his own manner. To make free from these difficulties, the subset theory was introduced by D. Malatsav in 1999. Subsets play an important role in converting real-life problems into mathematical problems. Suppose Mr. X goes to the showroom with his family members to buy a car. In the showroom, only 5 cars are available. Mr. X said that when we choose a car, we must mind the following attributes. The first one is that the car must be expensive, it must be beautiful, have a comfortable sitting arrangement, and be colorful. Based on these parameters only, they want to choose a car. The family members have their own opinions on choosing a car. So now Mr. X is totally confused about that what is the correct choice. So this is a very simple real life problem how to choose the correct option. A pair FE is called a subset where F is the function from the parameter set E to the power set of the object set U. Let U be the set of 5 cards and E be the set of parameters expensive, beautiful, comfortable sitting arrangement, and colorful. Then the subset that describes the attractiveness of the cards may be written as follows. Here U1 equal to C2 means the car C2 is expensive and so on. Now it is time to discuss our work in this paper. First, we wrote a summary of the article in the abstract section. Now let's look at the abstract of the article. The subset theory offers a wide range of applications in various domains. The subset is more general and capable of controlling unpredictable data than other current apparatus such as fuzzy set theory. On the other hand, at whatever point we come from the term cryptography, the primary things and probably the only things that comes to our intellect could be private communication. This paper's important reason is to present a new crypto system in which both the key and the plain text are of a subset environment. We have proposed the definitions of the soft crypto system. At that point, we introduced symmetric and asymmetric crypto system in a subset environment. We have created two new theorems. Utilizing this concept, we have arranged two algorithms to encrypt the plaintext and decrypt the ciphertext. Besides, a numerical illustration to solve a banking problem with our proposed crypto system has been displayed. The keywords are subset, crypto system, encryption algorithm, decryption, restricted symmetric difference. Then we reviewed the literature in the introduction section. This means that in this section we have discussed the work done by some researchers. In section 2, we give some basic concepts about subset theory. In the preliminary section, we recalled some definitions to smoothly realize the rest of the papers. Icon introduced a soft crypto system in which the subset is taken as a key and plain text as usual language. Motivating from Igon's work, we prepared this paper in which both the key and the plain text in a crypto system are of a subset environment. Section 5 proposes the definitions of symmetric key crypto system and asymmetric key crypto system with examples. Here we also proposed two theorems. The first one determines the size of the possible key space of our proposed crypto system, and second one ensures the well-defined key structure. In section 6, Two new algorithms are proposed. The first one deals with producing a new message from the actual message, and the second one deals with returning the actual message from the transferred message. In section 7, we have checked and verified the security of our crypto system through a numerical example. In section 8, we have discussed the future works. In section 9, we compared the security behavior of the proposed crypto system with some other classical ciphers. In section 10, we give some limitations of our proposed work. Finally, we have concluded our work. This is the list of references. Thanks for watching.